Wagan ya little nannies. Wa alaikum assalam habibis. Hey, but check this. Man's in the classroom right now with some youth called fucking Divide. Divide? It's David, you pussy. You think man's a calculator or something? I listen, don't talk smack. Just because we're on school premises don't mean I won't catch you on the streets and make you go through the strangulation process. I suck your mum, you broke you. I listen, don't talk tough. I might be broke, but man's rich in the skull, you understand? Man's rich in the mind, a little elevation thing. Anyways, look, let's jump straight into this. A little light work thing as usual. Man's gonna take difficult and make it simplification. So give me a sec. Let me drink a little something. You don't know the pattern. Okay, a little something to get me started. So, okay, cool. Now, before I get into this, there's a couple things we need to understand. I've done 3 videos before, okay? So one of them was statics of a particle, intro to pulleys, and then connected particles. So go watch that car. I'm not going to be able to explain all of that in this one video, but if you watch them and you fully understand them, then this one's going to be a bit more easy. So please go do that and then come back to this. Anyways, let's jump straight to this. Cool. Now, there's a couple things we need to understand before I get into this. The top right here says the string is inextensible. So I'm going to repeat what that means one more time, okay? Now, this is the pulley, okay? This is the pulley right here. Cool. We've established that. Now, if the string is inextensible, what that means is you see this string here, yeah? If it is inextensible, the tension is towards the pulley. So T here. So remember, this is the pulley. The tension is towards the pulley on both sides and the tension is equal. That's what it means if it says the string is inextensible. All right, cool. Let me rub that out now. Next thing, it says the plane is not smooth. Okay, cool. If the plane is not smooth, and by the plane they're talking about this thing here. This is the plane, okay? So they're just talking about the concrete, the floor, you get me? This 5 kg is sitting on the plane, yeah? They're saying it's not smooth. Now, if it's not smooth, therefore, there's friction. Okay, I hope you understand what I mean. So basically, let's say if you're, running up a hill, okay? You're running up. There's a couple reasons why you get tired. One of them being, okay, the concrete is pushing back down. Something called friction. You understand? So when you're running up the hill. Firstly, it's difficult for many reasons because gravity, all this stuff. There's a lot of variables we'll get into later. But one of the main ones, obviously, is friction. The concrete is pushing back down. You get me? So that's what that is, okay? And this is what it means by if it's not smooth, therefore there's friction there. Okay, cool. Let me rub this out now. What else does it say? It says the system is released from rest. Okay, cool. The system is released from rest. Now, I want you lot to just sit down and just think for a second, yeah? Let's say, hypothetically, this was a real-life situation, okay? So, there's 10 kg here, and there's 5 kg here, and, this is happening in real life. What happens? Obviously, the 10 kg is going to go straight down like this. It's going to accelerate straight down, because it's much heavier than the 5 kg, but because this is an inextensible string, what's going to happen is, this 5 kg is going to go straight up 8 meters per second squared. I hope you understand what I'm saying. Let me repeat that one more time for you lot. I'm going to repeat that one more time. So basically, yeah, what's going on here is this 10 kg is way heavier than the 5 kg. We've established that, okay? And this is connected by an inextensible string. So basically, this 10 kg is going to go straight down 8 meters per second squared, okay? And if the 10 kg goes straight down, the 5 kg is going to go straight up like that. It's going to follow the arrow like that, okay? 8 meters per second squared. Actually, you know what? Let me draw it a bit more up, my bad. Let me draw it up here, innit? 8 meters per second squared like that. Calm, little light work thing. Okay, now we've established this. Now listen. You see this 5 kg, there's a lot we need to know about it. But what I'm going to do is I'm just going to give you a quick example, okay? Let's say there's a man, okay? This man is standing on a hill, okay? This man is standing on a hill. Now I have a question. Why isn't this man flying down? Why isn't he flooping down? Like, why isn't he crawling down? Why isn't he rolling down? They see me rolling. I'm joking. Listen, serious question. Why isn't my man rolling down? Now there's a couple variables. Now listen, let's get into this, yeah? I need you lot to remember this. Weight is equal to mg. I don't know if you lot remember this from my previous videos, I hope you do. So weight equals mg. Now let's say this man here is 80 kg. Okay, let's say he's 80 kg. So therefore, weight is going to be mass 80 times gravity g. Now g tends to be 9.81. Okay, depending, they can tell you 9.81. Sometimes they can tell you 10. We're going to stick with 9.81 for now. So g is equal to 9.81. Now, There's a reason why he's not, you know, crawling down, flopping down, rolling down, okay? That's because his weight is going straight down like this, AEG. Okay? Now, when we've discovered this, okay, now, this AEG, I don't really care about the AEG. What I do care about is the components that come with the AEG. Once we find out, okay, the mass is going straight down towards the center of the planet. This is planet Earth, you get me, fam? So the AEG is going straight down, but what we do care about is the components that come with that AEG. You understand? So this AEG has got a vertical component like this, okay? And it's also got a horizontal component. This vertical component is going straight down like that. This horizontal component is going straight down like this, okay? I hope you understand this. Now, let me just rub that out, explain this one more time. There's also one other thing I want to add as well. There's normally an angle here. Let's just say that angle of the mountain is like theta, okay? Now, what we do is, as I said, we don't care about the AEG. We care about the components that come with the AEG. So it's the one going straight down like this, okay? And then the one going straight towards the AEG thing like this, okay? So this one's the vertical one. This one's the horizontal one. Calm little light work thing. Now, this is the really important bit. This angle theta, whenever it's given to you, automatically you're going to put the theta right here. Always, okay? Now, there's proof to this, but I don't really need to go into the proof. You don't really need to know the proof. If you really want the proof that bad, if I get too many requests, I don't mind going through the proof, but it's not really that deep. All you need to remember is when the theta angle is given here, once you draw out this little triangle thing, you're just going to put theta in that corner up there like that. Calm little light work thing. Now, next step. As I said, we don't care about the AEG, we care about the components. Now, we found the components. It's this one and it's this one, okay? The question is, what are those components? Now, this line right here, because it's closest to the angle theta, it's going to be AEG cos theta. Now, if you don't understand what I've done here, I've done a video on this. I think it's like a 4 or 5 minute video. It's something to do with finding the line given an angle or something like that. I don't know. It's like a 2-3 minute video. Go watch that. Or you can watch my Sokoto video, whatever in it. I hope you understand what I'm doing right now. So this AEG cos theta is this line going down here. Now, the reason it's cos is because it's the closest to the angle, okay? Now, this line here is the furthest away from that angle there, yeah? So, therefore, it's sine. So, this one here is AEG sine theta. Once you've discovered this, man don't care about the AEG anymore. I only use the AEG to find these two components because that's the most important in these types of questions, okay? We don't care about the AEG. We care about the components, the AEG cos theta, the AEG sine theta. Calm little light work thing. Now, next question I have for you lot. The next question is, why isn't my man, let's think about this here, why isn't my man going straight through the ground? Why isn't he going straight down? Like, why isn't he digging down through the concrete? You understand? For example, if you're standing in your room, yeah, and you're standing still, why aren't you digging down? Why aren't you going deep down? The reason being, yeah, is because the concrete below you is pushing back up equal force, which is why you stay put. For example, if you punch the wall, why doesn't the wall break? Reason being is because when you punch the wall punches you back with the same force. That's why nothing happens. The only thing that happens is you're probably in pain, fam. You get me? Your skull, your arms, your bones is cracking. You understand? But that's unless you obviously you got a wall made out of paper. That's a different story. But most cases, if you punch a wall directly straight in, nothing's gonna happen to the wall because the wall pushes back with equal force. So you just meet in the middle and it averages to 0. You understand? Okay, cool. So therefore, the reason why my man isn't going straight down is because, as I said, he's got the force, the concrete here is pushing straight back up, okay? And that force is pushing back up is what we call the reaction force. So it's pushing straight back up. So remember, this plane here is pushing straight back up, and we call that the reaction force, okay? Okay, let me just rub that out. So I hope so far you're understanding what I'm saying, okay? So that's the reaction force. All right, cool. Now, the question is, what is the reaction force? Okay, cool. The reaction force is going in this direction. So therefore, it must be equal to whatever it's going down with in this direction. Now, looking at these forces, which one is going to be the reaction? What is the reaction going to be equal to? Is it going to be equal to AEG sine theta, which is going in this direction here, okay? Or is it going to be equal to AEG cos theta, which is going this down here? You lot tell me, innit? I'm going to let you lot think about that for like 2 seconds. Let me just rub something out quick. This arrow, I don't like this arrow here. I can't lie to you. So, so tell me, what's the reaction going to be equal to? I hope you said AEG cos theta, okay? Because remember, as I said, up, the reaction R is going in, which is this one, is going to have to be equal to the opposite direction the other force is going in. And the only other force going into the opposite direction of R is AEG cos theta. You get me? Because look, this force here is opposite R, and that is AEG cos theta. So therefore, R is equal to AEG cos theta. Okay, so look, so far, I hope you're understanding everything I'm saying. Okay, I really hope so. I really, really hope so. Because now we're going to get into the question, and I wanted to just fully explain this to you in a real life situation. So when we go into this particular question, you're going to understand using the principles we just went through. Okay, cool. Let me rub all of this out now. Give me a second. Let's see if I can rub it out using this. Yeah, that's nice. That's nice, though. Because before I had to rub it out manually, you get me? Man's found a little trick on that. Okay, cool. So, I don't know why the W equals mg, right? Okay, let me rub that out. Let me write that out again. Alright, W equals mg, yeah, cool. Now, let's get into this question. The first thing I'm going to do is I'm going to label this side here A. I'm going to label this side here B. And by A, I mean this one's A and this one's B. Okay, cool. Now, let's get into the forces. So, remember in the very beginning, I told you it's an inextensible string. Therefore, this tension here is equal to this tension here. Cool. That's the first forces we're looking at. The next thing we saw was, I said, if there's a guy and he's going up and he's running up a hill, friction's pushing him down. That's why he's getting a bit tired. You get me? Now, this 5 kg is going up. So, therefore, friction's going to be going down this side. You get me? So, let me rub this out and let me just, let me write it out again. So, the friction's going to be going down like this. Okay, cool. Now we've discovered that. Now we're going to go into the more, difficult stuff. So let's look at the 5 kg. We know there's a weight going down and the weight is going to be 5g. Okay, but we don't care about the 5g. We care about the components that come with the 5g. The components that come with the 5g is this vertical one right now, which is going straight down. And there's this one right now, this horizontal one going straight down like that. You understand? Now, there's another thing we need to remember. There's 25 degrees here. So automatically, you put the 25 degrees right here. Calm, little light work thing. Now, I need to find this force and I need to find this force. Now, remember, as I said last time, because this one here is the closest to this 25 degrees, it's going to be cos 25. So, therefore, this is going to be 5g cos 25. Okay. And this one here is furthest away, so it's going to be 5g sine 25. 5g sine 25. Now, I'm going to rub out the 5g because it's getting too messy. But you can normally leave that there if you want. Okay, let me drink some water. Give me a second. Okay. So let me draw out this 5g. Cool. Alright, cool. Now that we're here, listen, don't watch that. We're nearly getting there now. We've discovered that. Now remember, as I said, these always have a reaction force. The reaction force going straight up. Because remember, yeah, I said to you lot, why isn't this 5 kg going straight down into the concrete? The reason being is because the concrete is pushing back up with a reaction force, okay? Now, the question is, what is the reaction force equal to? Okay, so we know the reaction is going to be equal to the force going in the opposite direction of it, yeah? Now, the only one going into the opposite direction of the reaction is 5g cos 25. Because remember, 5g cos 25 is going straight down like that. You get me? So that's why R is equal to 5g cos 25. So R is equal to 5g cos 25. Calm, little light work thing. Now, okay. I have another question for you lot, yeah? What is the friction equal to? Okay, now, if you've watched my previous videos, there's an equation. Friction equals mu R, okay? Now, mu, in most cases, is given. Let's just say mu is 0.2, okay? In most cases, it's given. And always remember, mu is always between 0 and 1, okay? So, mu is equal to mu R. So, mu, we just said 0.2. So, I'm going to put 0.2 right there. And that's equal to the reaction force, which is 5g cos 25. Now, we're lucky because 0.2 times 5 is just 1. So, we're just going to be left with g cos 25. So, let me just rewrite all of that. So, it's just going to be g cos 25. Alright, listen, now that we've got this, I can rub a lot of the stuff out. Obviously, you don't have to. I'm only going to do it just for simplification purposes, yeah? So, this reaction force, I don't really need it anymore. I only used it to calculate friction, okay? And then this friction, I can replace it now with, well, what we just found it to be g cos 25. Calm, little light work thing. Okay, now, because remember, it said friction here, but we just calculated that friction is going to be equal to g cos 25, so therefore I just replaced it, okay? You can do this manually, you can change papers and continue, but I'm just doing it here because I need the space. I ain't got enough space. Okay, now, what I'm going to do, now we can solve. So I'm going to redraw the 5 kg. Okay, now, I'm going to draw all the forces acting on it. So right now, we're looking at A. Okay, right now, we're solving for A, okay? Now, if we look at the 5 kg, we're going to look at all the forces acting on it, okay? Now, first things first. We know it's going up, and that's positive. That's what we've labeled for A. Okay, so what I'm going to do is next to A, I'm going to put up is positive like this. So I'm going to look at all the forces in this direction. So we're going to look at all the forces going in this direction, all the forces going in this direction. That's it, okay? So looking at the 5 kg, the first one is T. Okay, that's acting on 5 kg. So T is going up like this. Okay, cool. What other forces? The G cos 25 is acting in the opposite direction of T. So man's going to put G cos 25 going down like that. What other forces? What other forces are going into the same direction as G cos 25? I hope you said 5G sine 25, okay? Because that's what we care about. This 5G sine 25, look, it's going down in the same direction as this friction. You get me? That's what's acting on it. So man's going to put 5G sine 25 going down like that. Calm! And this 5G cos 25 has got nothing to do with it, okay? This 5G cos 25, when you're resolving for forces, the 5G cos 25 has nothing, this one has nothing to do with it. We're only looking at the ones that are going in these directions here, okay? And 5G sine 25 is going into the same direction as G cos 25. So therefore it acts. Okay, listen. I hope so far you're understanding what I'm saying. I really, really hope so, okay? Now I'm going to solve. So we know the equation we use. The equation we use is sum of the forces is equal to mass times acceleration, okay? Now the sum of the forces, let's look at this, okay? So we know up is positive, okay? So T, is it going to be positive or negative? It's going to be positive because it's going in the same direction that we've put positive. So man's going to put plus T. Looking at the other ones, G cos 25, is that going to be positive or negative? It's going to be negative because we've put up as positive, but G cos 25 is going down. So man's going to put minus G cos 25. Okay. 5G sine 25, is that going to be positive or negative? It's going to be negative because obviously up is positive and 5G sine 25 is going down. So man's going to put minus 5G sine 25. Alright, cool, and that's going to be equal to the mass times acceleration. The mass, obviously, we know is 5 kg, so 5 times A, because we don't know A. So that's going to be 5A. Alright, cool, now man's going to do a little simplification. So T minus, if you put this in your calculator, so 9.81 times cos 25, sorry, minus 9.81 times cos 25 minus 5 times 9.81 times sine 25, because remember the G is 9.81. If you put this in your calculator, make sure you're on degrees mode, you should get T minus, wait, let me double check that because I don't want to talk once. You should get minus 29.6. And that's equal to 5A. Calm, listen, that was the hard bit done. So I really hope you understood what happened here. That was the hard bit done. Because now we're going to look at B and it's going to be light work. So listen, I'm going to have to rub everything out because this is too nuts, okay? Let me just rub all of this out. So just remember this equation. This is equation 1, okay? Give me a second. Because this is just too messy right now, I'm telling you. Alright, cool. Now, so what I'm going to do actually is let me just put equation 1 down here. Let me just rub out reaction and that. Give me a second, give me a second, give me a second, give me a second. Don't go anywhere, give me 2 minutes, man, give me 2 minutes. Alright, so remember, equation 1, we found it to be, what was it? It was, we found it to be, shit, I think it was T minus 29.6 is equal to 5A. Alright, now I'm going to solve for B, okay? Now B, we know down is positive, so that's the first thing I'm going to say. I'm going to say down is positive, okay? So B and down is positive. Alright, cool. Now, before I continue, there's a couple things we need to remember. This 10 kg here, is there any other forces acting on it apart from T? And yes, there is, the weight, okay? So this is going down, weight, which is mass times gravity, so 10 times G, and that's it. That's the only forces acting. That's why B is much easier than A, because this one was nuts. But B is a little light work thing, okay? So now I'm just going to resolve for this, okay? That's all I'm looking at right now. Alright, so we're looking at B right now. Down is positive. So remember, sum of forces is equal to mass times acceleration, okay? Now, the sum of the forces, cool. So down is positive. 10G, is it going to be positive or negative? It's going to be positive because down's positive and 10G is going down, so 10G is positive. So I'm going to put 10G. But the T, is that going to be positive or negative? It's going to be negative because A is down, sorry, down is positive, but T is going up. So therefore, the T is negative, okay? So minus T, and that's going to be equal to mass, which we know is 10. So man's going to put 10 right there, times the acceleration, 10A. Calm, little light work thing. Listen, this is equation 2, okay? We're basically done now because I'm going to take equation 1, T minus 29.6 is equal to 5A. Okay, and equation 2, what I'm going to do is I'm just going to swap these places around. So I'm just going to write minus T, give me a second, minus T plus 10G is equal to 10A. Okay, remember that 10G is not, remember G is 9.81, okay? Now I'm going to add these equations. T plus minus t is going to become 0t. That doesn't matter. Minus 29.6 plus 10g. Okay. Minus 29.6 plus 10g. That's going to be equal to 5a plus 10a. That's going to be 15a. Calm little light work thing. So now you've got minus 29.6 plus 10g is equal to 15a. What I'm going to do is I'm going to divide both sides by, let me write up here. I'm going to divide both sides by 15. 10g over 15. And that's going to be equal to a, okay? That's going to be equal to a because obviously we're trying to make a the subject. So what you're going to do in your calculator, you're going to put minus 29.6 plus 10 times 9.81, divide that by 15, and hopefully you should get a is equal to 4.56, okay? Calm little light work thing. Now that we get here, it's easy. Let's say if we take equation 1, you can take equation 1 or equation 2. Equation 1, what I'm going to do, I'm looking at equation 1 right now. What I'm going to do is I'm going to take the 29.6 to the right hand side, okay? So if I do that, I'm going to get t is equal to 5a plus 29.6. But we know a now, we just found it, so we can find t. We just put 5 times a, which is the 4.56, plus the 29.6, and you should get the answer being 52.5. Calm! Hey, listen, the tension's in newtons as well, yeah? 52.5 newtons. Listen, I hope this video helped, you know, put some knowledge and, you know, some knowledge in your skull. But apart from that, listen, don't watch that. More parts coming soon. Love.